The very first one is no other than side, side, side. You guys remember seeing these on your proficiency scale?
Yes.
And you're like, what the heck is SSS? SA? What are all these things? Well, that's what we're learning today. So basically what this theorem says, this postulate, if all three sides of one triangle are the same size as all three sides in the other triangle, then the triangles will be the same size. They are congruent. So did I have to ask a single angle? No. If you would have asked me in the game we just played all three sides, that would have been enough information to create a triangle the same size as mine. So this is the first one. It's called side, side, side. Okay? This is called an included angle. And so basically the way that I would use this is I would say angle B is included between sides AB and BC. So what does included basically mean? It's the angle that is formed by the two sides. So this side, this is a side, right? The angle in the middle, and then on the other side of that angle, we have another side, which sets us up for side, angle, side. So this is called SAS. So basically, what this means, let's say I know that one side is exactly 2 inches. And I know that the included angle, the angle in the middle, is exactly, let's say, 32 degrees. And I know that this side is exactly 3 inches. Could I now finish the triangle without asking any more questions?
Yep.
Yeah, you know, if this is exactly 2 and this is exactly 3, and these two are locked in at 32 degrees, then we know that this side will be that length, whatever it is, right? So you could have asked a side, an angle in the middle, and another side, and your triangle would have been the same size as mine. So that is our second theorem. So take a look at this proof. I think it's on the back side of, so basically all the theorems and postulates are on the front, and on the back are the examples. So first of all, this is given to us. This is given to us in the picture. In other words, they've marked it on the picture. They haven't said it, but can you see on the picture how they put a tick mark on AB and a tick mark on DB? That means that those sides are congruent. So we know that this is congruent to this because they showed us in the picture. What theorem, and this is the second time we've done it today, it's probably 2 of about 50 times that we'll do it in the next 2 weeks. Which theorem says, or postulate, or property says, something is the same size as itself? Reflexive, good. Transitive is if A is congruent to B and B is congruent to C and A is congruent to C. Reflexive, property of congruence. Now, why is that important in this scenario, that BC is the same size as itself? Exactly. It's that one segment is the bottom of the top triangle and the top of the bottom triangle. Does that make sense? So by saying it's congruent to itself, you're kind of killing 2 birds with 1 stone, and that's the same side in both triangles. So now, there's another given. What else did they mark in the picture? Yeah, angle ABC. And I have to use 3 letters here because there's 2 angles coming off of angle B, off of vertex B. So ABC is congruent to angle CBD. Or you could call that DBC, but B has to be in the middle. And that's also given by means of the picture. So a lot of times they give it to us in like a sentence. In this case, it's just part of the picture. Now separate out the 2 triangles. Look at the top triangle. How many things do I know?
2, 3.
3. I know the top side. That's side, right? I know the very next angle, and then I know this side in the middle. So in the top triangle, we have SAS, and that matches the bottom triangle that's also SAS, right? So the triangles, so now we can say this. That's always the last step. Triangle ABC is congruent to triangle DBC because of the postulate SAS.
So that was good ones.
Yep.
I was just about to say something about that thing and then you said it.
About what
The congruent, like the triangles thing.
Mhm.
Yeah.
Now this one's done for us, but you have to be careful. Look up here. This is not always blatantly told to you. But what do you have to remember if you were to come up with this on your own? What's so important about this statement right here that we always have to remember to do? Yeah, it has to be in corresponding order. So A is congruent to D. So those have to be first and first. Or they could be second and second or third, but they have to line up. Remember that. So always be careful that you check that as well. Okay? Next one. Is this on your notes? Yeah. Cool. So this one is given. Now you have to mark your picture. You will not do well on this test. I promise you. You'll get a D or an F on this test if you don't mark your picture, because you have to be able to see that there's a side, the very next angle, and then a side in the picture to understand the postulate that's happening. So get used to doing that. And that one's already marked for you. QR is congruent to QS. And then the next given, because there's another given, is the only other thing in the given we haven't said yet. So that's ray QP is bisecting angle RQS. And what does that mean exactly? For a ray to be bisecting an angle. It's cutting that angle exactly in half. So how do I mark that on the picture? Yeah, the two angles. So QR, that's this ray right here, is cutting in half angle RQS. So where do I put the two little arcs? Yeah, up top by Q, right? So this angle is congruent to this angle is what that's saying. So now we actually need to say that, though. So you can see the next reason is the definition of a bisector. So because it's bisecting, we know that it's cutting those two little baby angles exactly in half, or congruent to each other. So I would now say angle. What could I name this left one? What are some possibilities? RQP or PQR, the exact opposite. PQR is congruent to angle. Now what could I name the right side of this? SQP or PQS, but Q has to be in the middle, because Q is the vertex. And we marked it. You got to mark it. Now here's the third time we've seen this today. It's 3 of about 50 times you'll see it the next 2 weeks. What statement says, or what reason says that something is the same size as itself? Reflexive property of congruence. Reflexive property of congruence. That's going to happen every single time that I give you a picture where the triangles share a side. And which side do they both have in common? QP. You have to mark it. You have to visually see that those are the same size. So now, it's pretty clear to see. Do I have 3 things in each triangle? Yes. And what order are they in? Side, angle, side, and side, angle, side. They have to match. So they are congruent because SAS. And we know that what we're trying to prove is always the last statement. So triangle RQP is congruent to triangle SQP. And once again, they already have it written for you, but you have to make sure it's in corresponding order. Okay, we had an included angle. Now we have an included side. What do you think that means? That the side is between 2 angles. So what do you think this one's setting us up for? An angle, the side in the middle of another angle. The side has to be included for this to work. ASA. So now you can see on the front side, we have another one that's called ASA. Let's see.
There's one that's a bad word.
Okay, so this is easy to see if I draw an example. So let's say I know that this angle is 23 degrees. And I know that this side is 4 inches. And I know that this angle is 51 degrees. Exactly. Could you now finish the triangle? Yeah, that's basically like the concrete supports, right? But if this is 23 degrees, this has to keep going, right? And if this is 51 degrees, this has to keep going. So could you now finish the triangle?
Yeah.
Yeah, so all you had to ask was an angle, the side in the middle, and another angle. Okay, so take a look at this example. It's on the back again. Sorry, keep flip-flopping. We need to determine if we can use ASA for this example. So ASA, I'm going to go kind of fast here. We have a reflexive side, right? So kind of get in the habit of that. If you ever have two triangles backed up next to each other like that, just put a little tick mark on the middle side. Now, what do these two arrows mean? No, they're parallel. Be careful. That does not mean they're the same size. Basically, when this happens, it usually means we have parallel lines and a transversal. Remember that? Our parallel lines and transversal. Which basically what ends up happening is we have alternate interior angles, which are always congruent. But you have to be careful here, because the answer to this question is actually no. There's not enough information. Because is this, see from purple to purple, is that is the alternate interior angle to this, right? Remember, the angle has to be touching the parallel lines. But is that what's given to us? No, that's what it would need to be for alternate interiors to work. But they're chopped off. They're chopped off by the parallelogram. Well, I guess it's not parallelogram. We only know that one side is parallel. So no, those are not alternate interior angles the other way. The purple ones are, the blue ones are not. So this is actually kind of a fool ya problem. It looks like it, but there's not enough information for us to prove it. That's not a true alternate interior angle. Okay? I'm not going to really explain this one right now, but this is another possibility. AAS. But I do want to point out to you, why is this not ASA? Because we just learned ASA. Why is this one not ASA? Two angles and a side. Yeah, is the side in between the two angles? No. For this to be ASA, it would have to look like that. The side has to be between the two A's. It's in that order for a reason. So be careful. This is actually AAS. The side is not between the two angles. It's an angle, the very next angle, and then a side around the corner. So know the difference between those two. And then the last one is called HL. We talked about that one. What's H stand for? Hypotenuse? Leg. Now, not every triangle has a hypotenuse. What does a triangle have to be in order to have a hypotenuse? Yeah, it has to be a right triangle. So this is the only one where it has to physically be a right triangle. The other ones don't have to be a right triangle, like ASA, SSS, all those. This one does, okay? So now we're going to go over what does work and what does not work. So what was the very first one we learned? So these are the ones that do work and these are the ones that do not work. And we'll figure out more why this is the case next class.